Now here is the question. The diagram given below is the network for transporting oil from refinery A to deports B, C, D, E, F and G. The arrows indicate the direction in which oil flows, and the value above each depot denotes its capacity in 1000 liters. The supply is arranged such that only after a depot is full will the excess oil be transferred to the depot next in the supply line. The maximum capacity in 1000 liters of the pipeline connecting the refinery with the deports is 1500 and those connecting the deports is 750. The slack is in a pipeline is defined as the extra flow required to bring the pipeline to full capacity. The flow in the pipeline is such that the demand at each depot is completely met. So what is given in this question? There is a refinery. Let's identify the refinery. Here A is in refinery, and as it said in the question, in this part of the question, that this one B, C, D, E, F and G, these all are deports. B, E and all are deports. And there are two types of pipelines. The pipeline which is connecting from refinery to depot. For example, this red line, these pipelines are connecting from refinery to depot, and rest all, the pipeline which connects B and E or C and E or D to F, rest all which are in the blue color, you can see these pipelines are connecting from depot to depot. And there is two figures mentioned here, 1500 and 750. These are the capacity of the pipeline. So what is this 1500? This 1500 is the capacity of the pipeline which connecting from refinery to depot. That means the pipeline which connecting from A to B, its capacity is 1500. So is the case of A to C and A to D. The capacity of these pipelines are 1500. Whereas this 750, this 750, this is the capacity of the pipeline connecting depots. That means this pipeline B to E which connecting depots, so its capacity is 750. Same way the pipeline which is connecting C to E, this capacity is 750. So all these pipelines which are connecting one depot to another depot, its capacity is 750. Let's go to the question. Question 1. What is the minimum flow in the pipeline connecting A and D? So pipeline A and D is a refinery to depot and its capacity is 1500. What is asked? What is the minimum flow in this pipeline? To minimize in this pipeline, I need to maximize the other two, that is A to B and A to C. Okay. Before I find out how much is to be passed on from A to B and A to C pipeline, I need to find out what is the total requirement to complete the requirement of all depot. So we have, I can see that there are 6 depots are there. Let's count down what is the total requirement. So depot B we have 700 requirement, C 650, D 800, E 450, F 500 and G 900. So add all this, you can see that this 0, 5 plus 5, 10, carry 1, 9 1 10 19 plus 8 27 33 plus 7 is 40. That is 400 liters, 400,000 liters is the need. Now the question says, what could be the minimum flow in the pipeline connecting refinery A to D? Now see what could be the maximum supply from A to B. Can this be 1500? Let's check this one. The requirement for B is 700 and the rest will be passed on from B to E, and the B to E, the maximum flow could be 750, this pipeline. That means the inflow to B must be 750 plus 700, that is 1450. Anything extra cannot be flown out of B, and B cannot return more than 700. Therefore, the maximum inflow to B should be 1450. So this 1500 is not possible for A to B. Let's erase this one. So this 15, instead of 1500, it should be 1450. Come to pipeline A to C. We know C to E, there is only one outflow, and the maximum capacity this pipeline can take is 750. That means a pipeline connecting refinery A to depot C, the maximum flow in this is the requirement of C plus the outflow of C, that is 650 plus 750, that comes 1400. So the C can take 1400. Then what is the flow to A to D? And that too it is said minimum flow. That means that the balanced part has to be flow from A to D. So let's erase this 1500. Okay. Now come to this part. We have seen that the total requirement is 4000. So here already pipe A to pipe B, A to B pipe, that is 1450, and A to C, that is 1400. That means the total supply is 2850 is done through other two pipes. Therefore pipe A to D will be the remaining part, that is 4000 minus 2850, that comes 0 5 9 minus 8 is 1, and then 1, that is 1150. So what is the minimum flow in the pipeline connecting A to D? The minimum flow is 1150. So your answer is 1150. Question 2. If the pipeline connecting A and B is under repair, as a result of which its maximum capacity is reduced by 20%, then what is the minimum flow in the pipeline connecting D and F? Now, where the capacity is reduced, which pipeline has a capacity reduced by 20%? Pipeline A to B. So this pipeline it's talking about, it's reduced by 20%. That means the total capacity was 1500. So when it reduced by 20%, that means it's left over with 80%. So 0.8, which comes 1200. So this pipeline capacity is 1200 now. Next, the question is, what is the minimum flow in pipeline connecting D and F? Let's identify the pipeline connecting D and F. So this is red one, connecting D and F. I need to find out the minimum flow in this pipeline. Let's see the pattern of the flow. Now A to B, we know the capacity is 1200, where 700 will be is the requirement of B. So remaining 500 will pass on to next. Fine. So this F requirement can be passed on this entire 500 through this pipeline via E to F. So the need of F is done by this 500, which comes from A to B, B to E and E to F. Now take A to C. Now see, the maximum it can take is 750. That means the maximum flow from A to C is 1400. That is the sum of this 650 plus 750. Now when this 750 goes to E, this one, the requirement of E is 450, and the leftover part, that is 750 minus 450, that is 300. So this 300 will be passed on to G. So what is the additional need for G? 600, and that need I will take from this pipeline, that is D to G. So let's check, from D to G I can take 600 or not. A maximum capacity is 1500, but the maximum amount which can flow from here is 750. So 750 plus 800, it comes 1550. That indicates that this pipeline can take 1500 flow. Okay, let's erase this. Now, so when we take 1500 from A to D, 800 is the requirement of D. The remaining 700 will be passed on from D to G, but the G additional requirement is only 600. So we don't need this 700, so we need here 600. If this is 600, the flow in pipeline A to D must be, it's not 1500, it should be 600 plus 800, that is 1400. So in this way we fill all the deports without floating any quantity of oil through D and F. That means D and F could be 0. So this is my answer. So answer is 0. And at the same time check from these three pipelines, A to B, A to C and A to D, whether the total is 4000 or not. So I can see that 1200 plus 1400, that is 2600 plus 1400 is equal to 4000. Next question. What is the maximum value in 1000 of sum of the slag in all the pipelines supplying oil to depot E? Depot E has two inward supply, that is these two pipelines. Let's mark this. Okay. The question says maximum value of sum of slags to all the pipelines supplying oil to depot E. So we need to find out the slack of this pipeline and of this pipeline, and that too maximum slack. So I will minimize the flow. So to minimize the flow, I will maximize this A to D, and the maximum A to D can take is 1500, of which the requirement of D is 800. The remaining 700 can be flown to G, where the G additional requirement is 200, which can be taken via F to G or E to G. Now the maximum quantity from A to B we have seen is 1450. How is that? B to E, that is 750 is a need. A can be flown from B to E, and the B can return 700, that is 700 plus 750, that comes 1450. It flows from here. Now 750 comes from B to E. A to C, A to C we know here it could be 750. So what is the maximum it can take? The maximum it can take is 1400. But can I take these two figures? To say that, I should know that the total output from A should be 4000, of which I have taken A to D is 1500. So when A to D is 1500, what is the remaining part? The remaining part is 2500. That means the 2500 should flow from A to B and A to C. So when I add this 1450 and 1400, it crosses 2500. Therefore, this is not the valid values. Now I need to change one of them. Let's change A to C. Now 1450 is from A to B. So from 2500, if I take out 1450, then the leftover is 1050. So this 1050 will flow from A to C, 1050. The need of C is 650. So this 1050 minus 650, you left 400. So 400 will pass from C to E. So this is 400 will pass from here. Now the total inflow to E is 750. This 750 plus this 400. That's total 1150, of which E requirement is 450. So take out this 450. So you are left with the 700. Out of this 700, 200 will pass on to G. So this G completely 900 is over, and the remaining 500 will be passed on to F. Okay. So this should be the flow. In this case, what is the slack to the pipelines which is connected to E? So D to E, the slack is 0, and C to E, the slack is 350. Therefore, this is your answer. 350 is the maximum slack of pipelines connecting to E. And the last question. If the slack in the pipeline continues, if the slack in the pipeline connecting D and G is 50, then what is the minimum slack in 1000 liters in the pipeline connecting E and F? So slack in which pipeline? Connecting D and G. So let's identify the pipeline connecting D and G. So we are talking about this red one. Here it is said 50 is the slack. The total capacity here is 750. If the slack is 50, that means the flow is 700. Okay, if the flow is 700 here and it comes through D and the D requirement is 800, therefore 700 plus 800, thus A to D must be 1500. Now what is the question? Question says, what is the minimum slack in the pipeline connecting E and F? Connecting E and F. Let's identify that pipeline. So we are talking about this one. Minimum slack. To minimize the slack, I have to maximize the flow of E to F. So whatever the requirement to G which comes through E, instead of passing through this one E and G, I will not pass from here. I will let them pass from this pipeline E to F, so that from E to F it will pass on to F to G. In the process, we will maximize the flow of E to G, E to F. As a result, you will have a minimum slack here. Let's see how can we maximize the flow from E to F. No. So as 1500 is the flow from A to D, so the remaining these two, that is A to C and A to B, the sum should be 4000 minus 1500, which is 2500. So this sum must be 2500, the flow of A to B and A to C. Now I can take 1450 for B, so the rest I can take A to C, that is 2500 minus 1450, you get 1050. So this 1050 is the flow from A to C. What about B to E? The B receives 1450, out of which 700 it holds, so the remaining 750 is passed on to E. And about C, it holds 650 out of 1050, and the remaining 400 is passed on to E. Now the E received 750 plus 400, that is 1150, out of which its requirement is 450. If I take out its requirement, the leftover part is 700. I will take this 700 from this route, that is E to F, not E to G. So when 700 is flown from here, 500, F will hold 500. The remaining 200 will be passed on to G. So I can see G receives from two deports, from F 200 and from D 700, these two. So the total is become 900. So in this process, I maximize the flow from E to F, which is 700. So if I go back to the question says, then what is the minimum slack in the pipeline connecting E to F? So what is the slack in this case in E to F? What is its capacity? Each pipeline connecting depot has an 750 is the capacity. out of which 700 is flown, that means 50 is the slag. So your answer is 50. Is it clear? Yes.